Hello, listener, and welcome to my presentation on how mathematics can help us figure out star age and stellar rotations. In the field of astronomy, stellar rotations are still relatively not quite understood yet, so our researchers try to figure out exactly what the hell is going on by looking at star cluster NGC 1651 as pictured on the right. Two key features of this star cluster is that it has a narrow stellar age range of 300 million years, which, while fairly old to us, is pretty narrow when it comes to stars and the evolution of stars in their entire lifetime. Another key feature is that it has an abundance of subgiant stars, which, compared to having a small age range, having such a wide variety of evolution is kind of weird. So our researchers try to get a closer picture as to what the hell's going on. So let's talk about how they got into this data. Well, first thing, looking at star maps, you can see that there's plenty of stars. Stars that are not even in the cluster hiding in the background that can confuse the data and make it all messy. So the research had to use a process of binding and confining this region, mixed in with some alpha and declination calculations and a whole bunch of coding to try to get rid of all the unnecessary stars. Then we had to use some our key formulas that we learned in math, well, in the researchers, and a few more, a bit more complex, as we see on the right, where they try to find the total luminosity of the whole cluster through this formula and the radius, so we can actually get the age and the brightness. But even with that, and as you go on, if you go on to do physics 164, that there's a lot of uncertainty when it comes to light. Things called photometric uncertainty, which is just how light acts, can be really troubling, and Poisson noise, which can give you a range of fake, uncertain data points. So it takes a lot of smarts and a lot of coding to try to get rid of this. And because of all this work, we get these lovely graphs. As you can see on the right, on the red, that this graph is not exactly fitted right. That's the current theoretical model. And when we fit an actual fit to it, as the dotted blue line, we can see that this is a lot more what our extended turnoff region is what they call it actually looks like. And so they were really concerned like why the theoretical wasn't matching up with the hypothetical, with the actual. So they actually decided to look up all and date all the stars in this region, all 35 of them, and show that they have widely ranging ages and datas, even though they're all of similar make and they all should be around the same size. So what our researchers came up with is that stellar rotations is the only viable option in this uncertainty. But many authors have disagreements on that, saying that the stellar rotation doesn't really play a role in the stellar age, that whatever it does with its mass is non-negligible, while the researchers argued that because of the rotation, the star is able to keep its mass much more efficiently, meaning that there'd be more fuel for the fusion reaction, leading to a longer, much healthier lifestyle. But this is not the only research these researchers did, as they did another paper, which my partner will get more into in her project. So for now, that will be it for me. Thank you.